Hey everybody, so this is the solution video for Worksheet 6.2. We're going to be talking about properties of log functions. Now, I'm sure you've talked about them in lecture, but we'll be referencing the properties of logs, and if you need a reminder, you can find them as theorem 6.6 in your text on page 438. So we'll be referencing those with each of the problems we're going to do here today. Okay, so let's start in number 1 with part A. We're asked to expand the given logarithm and then simplify if possible. So we'll look at part A. We've got the ln of x cubed, and we want to think if we can use any of the properties of logarithms to expand this. So we can look for products, quotients, and powers of our argument that we could maybe rearrange. In this particular case, we've got our argument is x to the power of 3. So the whole term inside the logarithm is being raised to the power of 3. Because of that, we can rewrite this as 3 times the ln of x. So that's using one of those properties that are found in theorem 6.6. We can take, as long as the entire argument is being raised to a power, we can put that out in front as a coefficient. Okay, so that was easy enough. Part B, we've got the ln of x cubed again, but now we're multiplying that by y squared. So we look at this, and before we can really do anything with these powers, we see, well, we've got the ln of a product of two values, namely x cubed and y squared. So we can break that up as a sum of logarithms. So let's go ahead and see how we could do that. So using the fact that we've got a product, we can rewrite this as the ln of x cubed plus the ln of y squared. Now, at this point, each of these logs have arguments that are being raised to powers. In the first one, we've got x cubed, which we know from the last one can be rewritten as 3 times the ln of x. And in this case, we've got the ln of y squared, which we rewrite as 2 times the ln of y. And then this would be our solution. Okay, so for part C, we've got the log base 5 of z divided by 25. So here we've got a quotient of two values inside the log, in this case log base 5. So we'll use the property that allows us to expand logarithms of quotients. So we can rewrite this as the log base 5 of our numerator z minus the log base 5 of our denominator, in this case 25. Now, we may not notice it at first, but we can actually simplify this right here. There's nothing we can really do with the log base 5 of z. No more products, quotients, or exponents to simplify, but we actually know that the log, let's do this over here, we know that if we've got the log base 5 of 25 is equal to, well, is it actually being able to be simplified to something? We could think about it in terms of the problems we saw in 6.1. We could rewrite this log expression as an exponential. So we're asking ourselves 5 to the power of what is equal to 25? Well, we know that that exponent would in fact be 2. So we could actually simplify this a little bit further and say that this is going to be the log base 5 of z minus 2. And then that's really as far as we could take part C. All right, so part D is very similar, except here our quotient z over 25 is being raised to the power of 3. So at this point, we should know that we can take that exponent, put it out front. So we've got 3 times the log base 5 of z over 25. I'm going to take this in steps so we don't get ahead of ourselves. Now, we know what this is. So we're going to go ahead and we're going to make that substitution based on our work in part C. So that's going to be equal to 3. And I'm going to put this in parentheses. So we've got the log base 5 of z minus 2. So we know that from above. And the reason that's important is because that 3 is actually going to have to be distributed to each of these two values. So the final solution here would be 3 times the log base 5 of z minus 3 times 2, which would be 6. So that would be our most simplified version of this problem here. And then the last one we've got e, which asks us to find the log base 5, or expand the log base 5 of x squared minus 25. Now, there is no property of logarithms that allows us to expand a sum or difference of terms as an argument. So there's really nothing that we can do based on the way that we have this written. However, if we noticed that the term inside the log, x squared minus 25, is a difference of two squares and could be factored as such, we could rewrite this as the log base 5 of x plus 5 times x minus 5. Now we can apply a property of logs because we've got the log of a product of two terms. So using that property, we could rewrite this as the log base 5 of our first product, x plus 5, plus the log base 5 of our second term that we're multiplying, which would be x minus 5. And then that would be as far as we could take this. So again, there's nothing we can do to break these up individually because they're just sums of differences. It has to be a product, it has to be a quotient, or it has to be an exponent that's applied to the entire argument within the logarithm. Okay, so that does it for number 1. So there we were expanding logarithms, which is going to be an important part in calculus when we get to logarithmic differentiation. So it's definitely a good skill to have. Now here we're going to be talking about how to take expanded logarithms, multiple logarithms, and combining them into one logarithm. This is going to be a very important skill for section 6.4, where we'll be solving logarithmic equations and logarithmic inequalities, we'll see. So being able to combine these together using the same properties we talked about in part 1. So sort of in reverse. So we'll start with part A here. So we're asked to write the following as a single log. We've got the log base 3 of x minus the log base 3 of y. So we've got the difference of two individual logs. We know that we can rewrite this as a single log in the following manner. The log base 3 of x divided by y. And then that would be our solution for this one. So now we go down to part B. Similar problem, except now we've got this coefficient 2 to worry about. In general, with these combining log type problems, if you've got coefficients, take care of those first. Make those exponents of your arguments, and then go ahead and look for combining differences or sums of logs with the other properties. So we're going to go ahead and we're going to do that. We're going to take care of that coefficient first. And we're going to rewrite this as the log base 3 of x minus the log base 3 of y, and we put that up as an exponent squared. Now we go ahead and, like in part A, we can write this as the log of a quotient of these arguments. So we've got the log base 3 of x divided by y squared. And that would be as far as we really need to take this one. So maybe a note on this, that you're done with these problems when there are no coefficients. You've got the log of just one expression, and that would be considered a simplified single logarithm. All right, so for part C, we're taking it up a notch because we've got 3 different logs to combine. Normally the way that I like to do this is start from left to right and put them together in pairs rather than try to do it all at once, but that's just sort of my taste. So what I'm probably going to do first is put these 2 together, check them all. There are no coefficients we need to move, so we can go straight to combining using the properties for sums and differences of logs. So first we've got the sum of these 2. So I'm going to write this as the log base 2 of x times y. And I still have that minus the log base 2 of z. So now we're going to go ahead and we're going to combine these 2 using the property for the difference of 2 logs as the log base 2 of x times y divided by z. And then that would be our solution for that one. Okay. So for number 3, we're asked to use the change of base formula to convert these expressions to natural logs. Now the reason we want to do this is because if we want to estimate the value of these types of logarithms, we're just trying to find a specific numerical value, there's no variables, we don't have a log base 5 button on our calculator if we're trying to estimate these. So the change of base formula, I'm just going to go ahead and I'm going to throw it up here. The one that involves the natural logs tells us that if we have the log base b of a, this is one way to write it, we can rewrite this as the ln of a divided by the ln of b. We could also use the common log, so log of a over log of b, but you always want to have the argument up top, and then the base b is the value in the bottom. So we're going to use this to solve part A and part B here for number 3. So using this formula, we're going to rewrite the log base 5 of 80 as the ln of 80, which we could get on our calculator if we need to estimate, divided by the ln of 5. And if we did type this into our calculator, you would get approximately 2.723. So the thing to note here is that this would be considered an exact solution, whereas this would be rounded to 3 decimals. So make sure that you're aware of what the question is asking. If they want an exact answer, you can just leave it as the ln of 80 over the ln of 5, but more than likely in these types of problems you'll be asked to round your solution to a certain number of decimal places, in which case you'll want to make sure that you do that. And then for part B, we've got the log base 6 of 72, so using that change of base formula we can rewrite this as the ln of 72 divided by the ln of 6. And again, we could just easily type this into our calculators to estimate, and if we did, we should get about 2.387 if we're just taking it to three decimal places. Okay, so that does it for the problems that use properties of logarithms, and we'll be using these again, like I said, in 6.4 to help us solve equations and inequalities. But that'll do it for this video, and I'll see you all in the next one.